we're going to do another look at this data to see if we can find what model fits best. Is it going to be a linear? Is it going to be quadratic? Or is it going to be exponential? And here to help us, as is often the case in these situations, is my son Xander. You say hi, everybody?
Hi.
He's working on a super secret picture that he'll show you when we're done with the problem. So, first thing I'm going to do is check my first differences. And I can see pretty early on here, this isn't going to go very far before I give up. 3 take away 1 is 2. 9 take away 3 is 6. 27 take away 9 puts me at 18. Those aren't the same. So I clearly am not going to be using a linear relationship here. When I look at the second difference, the difference of the difference, which if you have an older sibling or relative that did calculus, this would be your first derivative and your second derivative. When we talk about the second difference, 6 take away 2 puts me at 4, but 18 take away 6 puts me at 12. Those don't match. So since I'm already getting different values for the second difference, I can rule out quadratic. That leaves one possibility. That means we need to look at the ratios. Do I have a constant ratio for all of my y's? Now remember, these tests only work when the interval between my x's is the same. And once again, I'm using jumping up by factors of 2. Problems will get harder as we go along, so we're using these easy numbers now to illustrate what's happening. Now my ratio, 3 divided by 1, 3. 9 divided by 3, 3. 27 divided by 9, 3. 81 divided by 27, 3. My ratio column is constants. Since I have that constant value there, I must conclude that I'm looking at some form of exponential variation or exponential growth. So my conclusion is that this graph is best modeled with some kind of exponential equation. You ready to show your picture, Xander?
Not yet.
Oh, but we're done with the problem. Can we show him a little bit of it?
Done.
Okay, we're going to stall while he finishes his picture. Remember, if the first difference is the same, we call that linear. If the second difference is the same, that's a quadratic. And if the ratios are the same, that's exponential. All right. We all have a good one. We're going to take a quick peek over here at what Xander's drawing. Let him finish it up later. We'll call it a night. All right, Xander, let's see what you got. Can you tell everybody what we've got there?
This is Superman right here. Even though you might not see his whole cape.
Come on in a little bit more.
And this is Batman right there, and there's a trampoline that he's going to land on. And I erased these two guys because I was going to change their faces. Because first, I put him and him sad because they thought he was going to land on the ground hard and hurt himself. But then someone put a trampoline there so Batman won't break his head open.
Well, there you go. You have a good night, everybody. Say good night.
Good night, guys.